Dear students, second paper khonor ami 4th unit to discuss kori asu ar 4th unit or prothom topic to ami already discuss korilu. Etia aji ami second topic to discuss korim, velocity of longitudinal waves in a fluid in a pipe. Yar note khini moi already tomalok di disu ar hekhini pora moi etia discuss korim. So velocity of longitudinal waves in gas, fluid, inside a cylindrical pipe আমি ডিসকাস কৰিম. সো লংগিটুডিনাল ওয়েভৰ ওপৰত ডিটেইল ডিসকাশন আমি অলৰেডি আগতে কৰি থৈছো, তোমালোকে বুজি পাইছা বুলি ভাবো. সো what we mean by longitudinal wave? By longitudinal wave we mean any wave in a medium in which a mechanical source, for example tuning fork, oscillating piston, or moving diaphragm of a speaker, etc., which causes physical displacement and compression in the material in direction in which the wave is propagating. So by means of these sources we disturb the medium, we compress the medium, we displace the medium, and that displacement or compression propagates through the medium. And to understand or to visualize how the longitudinal wave travels through a medium, let us see a video. Here a spring is, one end is attached and other end is free. So here firstly 2 point is identified by means of hanging piece of papers indicating A and B marked. So this point means we will firstly observe, we will create longitudinal wave, and how the points of the medium, how the points of the spring displace or behave when the wave propagates, we will see. So when we create disturbance, when we push the spring towards right, when we compress the spring towards right, then what happens? Let us see. So here if we compress the spring and then release, then that compression propagates, that disturbance propagates through the spring, through the material from left hand to right hand. However, simultaneously if we observe the behavior of the points, the point displace and again comes back to its original position. But what happens? The disturbance propagates through the medium by means of compression and elongation. সংকোচনৰ প্ৰসাৰণৰ দ্বাৰা ওয়েভ এটা, সংকোচন প্ৰসাৰণৰ দ্বাৰা ওয়েভ এটা স্প্ৰিংডালৰ মাজেৰে এটা পইণ্টৰ পৰা অইন এটা পইণ্টলৈ গতি কৰে, এটা পইণ্টৰ পৰা অন্য এটা পইণ্টলৈ গতি কৰে কৰোঁতে কিন্তু পইণ্টবিলাক বা মিডিয়ামৰ পাৰ্টিকলবিলাক ডিসপ্লেস, মিডিয়ামৰ পাৰ্টিকলবিলাকে মুভ নকৰে, ই এটা পইণ্ট সাপেক্ষে অসিলেট কৰি থাকিব. সো এনেদৰে আমি চাব পাৰোঁ যে হাউ লংগিটুডিনাল ৱেভ ট্ৰেভেলছ থ্ৰু দ্য মিডিয়াম. সো এইটো হ'ল এটা এনালগাছ সিস্টেম. আমি এতিয়া আমাৰ সিস্টেমলৈ গুচি যাম. আমাৰ সিস্টেমটো হ'ল gas or fluid enclosed in a cylindrical pipe. So here we have considered a cylindrical pipe of length L placed along x direction, and the area of cross section of the tube is say A. Now if we create longitudinal wave which exert pressure or force on the medium, then what happens? Any particular segment of the material, for example this segment experience force and hence displace towards right. and since the force on the points of the medium is different, so this point experiences different force and this point will experience different force. So as a result, what happens, gradient in force observe, we will observe gradient of force, and hence we will see a compression here. So firstly, deviation and compression of the segment. So when compression occurs, density of the medium increases, and this increased density again exert pressure in opposite direction. So exert pressure on the adjacent part of the segment, and in this way the displacement of the nearby medium occurs and compress. So in this way the longitudinal wave travels through the medium. So in order to obtain the velocity of the longitudinal wave, our strategy is we will use Newton's second law of motion, F equal to ma. So we will calculate firstly force on the segment, resultant force on this segment, and then will equate to mass times acceleration of the segment. So in this way we will find a wave equation, and that wave equation will be compared with standard equation for wave motion, and we will obtain velocity of the longitudinal wave. So to do so, firstly let us consider this segment with volume V1 where the gases are present at pressure P naught at equilibrium. So before allowing longitudinal wave to pass, equilibrium volume and pressure of this segment is V1 and P naught. Let when the pressure passes through the tube, P1 and P2 be the pressure exerting on the left hand and right hand of the segment. Since and resultant force will be what? Since force is P1A here along x direction and P2A will be in negative x direction, so resultant force will be P1A minus P2A. So due to this force, the segment will displace to this position. Here the left hand displaced through psi 1 and right hand displaced through psi 2. So new position of the two ends are x1 plus psi 1 and x2 plus psi 2 respectively. Initially their positions were x1 and x2. So we have clearly indicated the terms here. So if we consider the total force on the segment, which is equal to P1A minus P2A, this must be equal to mass times acceleration of the segment according to Newton's second law, where Ax is the acceleration of the segment in x direction, and here mass, which is expressed in terms of rho naught A delta x. Rho naught is the density of the medium, A is the area of cross section, delta x is the length of the segment. So here what we see is that mass equal to density into volume, means rho naught into V1. So V1 is what? Delta x into A. So mass equal to rho naught A delta x. one point we must observe here is that although rho naught is the density of the medium at equilibrium, so if the wave travels, then what happens? So let us consider the compression case. When it is compressed, then density increases but volume decreases. So means volume decreases, density increases, but mass will remain constant. So same mass, same gas molecules or same fluids are compressed here, so mass remains constant, although volume decreases and density increases. So here rho naught is the equilibrium density of material. Now let us define pressure at any point of the tube. So where, since we know that due to the wave, actually there is a force or pressure gradient is observed. So pressure is different at different points of the medium. At any point, if dP is the excess pressure or under pressure, over pressure or under pressure at a point over equilibrium pressure P naught, then the pressure at any point is defined in this way: P equal to P naught plus dP. dP is the change in pressure, deviation in pressure from P naught. So total pressure is P naught plus dP. So at the left hand of the segment, P1 is equal to P naught plus dP1, and at the right hand of the segment, let the pressure P2 be P naught plus dP2. So P1 minus force P1A minus P2A will be what? We will calculate it. P1A minus P2A equal to rho naught A x2 minus x1 del 2 psi del t square. Here actually delta x, small delta x, this is delta x is expressed in this way: x2 minus x1, same, and del 2 psi del t square, it is the acceleration. So here we have rearranged slightly. So del 2 psi del t square is equal to 1 by rho naught. Then area of cross section will be cancelled out from both sides, and here we will have P1 minus P2 and then x2 minus x1, and P1 minus P2 will give us dP1 minus dP2. So del 2 psi del t square equal to 1 by rho naught dP2 minus dP1 minus dP2 by x2 minus x1. So if we arrange this term in this way by taking negative side common, then 1 by rho naught dP2 minus dP1. Here we had dP1 minus dP2, but here dP2 minus dP1. So when x2 minus x1 tends to 0, means the segment length is very small, then we may write del 2 psi del t square equal to 1 by rho naught del dP by del x. So del dP is the incremental change in pressure. Again, from volume elasticity of material, we know what the bulk modulus, which is denoted by K, is equal to minus incremental change in pressure by volume strain. Here minus sign is because when pressure changes, pressure increases, volume decreases, and when pressure decreases, volume increases. So incremental change is dP and volume strain is dV by V. Here dV is the change in volume and V is the original volume before passing the waves. So here V is what? initial volume, that is A into x2 minus x1, initial volume of the segment AB, and dV is what? V2 minus 1, V2 minus V1, V2 minus V1. So V2 is what? A into x2 plus psi 2 minus x1 plus psi 1. Then V1 is x2 A minus x1 A. So if we consider, if we calculate the change in volume, we will have A psi 2 minus psi 1, and this is original volume A x2 minus x1. So we have minus k del psi by del x. So for small delta x, we express the incremental change in pressure as equal to minus k del psi del x. So substituting this pressure expression in equation 1, means here, if we replace that dP, then we have this expression, and this is the wave equation representing longitudinal wave through gas or fluid enclosed in a pipe. If we compare this equation with the standard wave equation, del 2 psi del t square equal to v square del 2 psi del x square, then we obtain v equal to root over k by rho naught. Here k is the bulk modulus representing elasticity property, elastic property of material, and rho naught is the density of the medium at equilibrium. So here we observe that velocity depends on elastic property and one inertial property of the medium, that is on k and rho naught. Thank you.